a buck-boost transformer, the current on the primary and secondary windings are not equal, although the power across the primary and secondary windings is equal. Power is the product of voltage and current. In other words, power equals voltage times current. The relationship between voltage and current in a transformer is inversely proportional. This means when voltage decreases, current increases, and vice versa, maintaining a constant power level, ideally. Consider an example of installing under counter low voltage 12 volts, lighting where the load is 1920 watts. While it seems that the current at the secondary should be 160 amps, given 1920 watts divided by 12 volts, the relationship is more nuanced when considering the primary side. On the primary side, with a voltage of 120 volts, the current is 16 amps, calculated as 1920 watts divided by 120 volts. However, the secondary should have 1920 watts equal to 12 volts times 160 amps. This highlights the transformer's function of converting voltage levels while keeping power relatively constant. The transformer is transferring power from the primary winding to the secondary winding. The power is equal to the voltage times the current. So, if the voltage is decreased, the current must increase to maintain the same power. In other words, the 120 volts is stepped down to 12 volts, so the current is stepped up. The current on the primary winding will be 16 amps and the current on the secondary winding will be 160 amps. To reiterate, the current on the primary winding is calculated as 1920 watts divided by 120 volts, which equals 16 amps. The current on the secondary winding is calculated as 1920 watts divided by 12 volts, which equals 160 amps. This inverse relationship is fundamental to transformer operation. To summarize, firstly, power remains relatively constant across the primary and secondary windings of a buck-boost transformer. Secondly, voltage and current are inversely proportional. If voltage decreases, current increases and vice versa. Thirdly, understanding this relationship is crucial for calculating current on both sides of the transformer given a known power requirement.